Hey everyone! For the second part of this week, week 15, we are going to be talking about desert landscapes. So a bit of a switch from coastlines and ocean landscapes. We're going to go through desert landscapes. Next week, we'll get into groundwater for part 1 of next week, and then glaciers, so glacial change, my personal favorite, for part 2 of next week. And then our very last week, we will talk about global change and how climate change and global warming are changing our landscapes and the geology that we see. So deserts, let's get into deserts. What are we going to do today? We're going to talk about what is a desert, how are deserts actually formed, and then we'll look at weathering and erosion that occur in deserts. As you can imagine, it's a bit different than the weathering and erosion that occurs on coastlines. We'll talk about deposition, sand dunes, and then we'll look a little bit about desertification, how human activity is causing increased desert landscapes. So to start, what is a desert? So a desert is an area that is so dry that it actually has no permanent surface water. So no water can exist permanently on the surface. There's no stream, there's no lake. They only have about 15% vegetation cover. So of this area, only about 15% of it is covered with vegetation. That goes hand in hand with the lack of water. And they usually have less than about 10 inches of rainfall per year. So deserts can exist in both hot climates and cold climates, which a lot of people don't realize, but they are generally considered the land of extremes. So deserts have they're extremely dry, and then either extremely hot or extremely cold. So we call it the land of extremes. About 25% of the land surface on Earth is actually considered to be desert. So there's sort of two different types, hot deserts and cold deserts. So hot deserts are at low latitudes, meaning they're close to the equator. Low elevation, so they're not, for example, on a mountaintop. They're generally far from oceans, and they have very high temperatures. So it's very, very hot. There are also cold deserts. So cold deserts are at high latitudes. They usually have high elevation, and they're near cold ocean currents, so they're in the poles. Temperatures are generally very, very cold. So there are two different types, cold deserts and hot deserts. Hot deserts are more abundant than our cold deserts. So we're going to go through these 4 different types of deserts. We have subtropical, rain shadow, coastal, and polar. We're going to look at the differences in the landscapes and what actually creates these different types of deserts. So the first one is a subtropical desert. So a subtropical desert occurs between 20 and 30 degrees north and south. So here. And also here, both in the northern and the southern hemisphere, we have these deserts. And the reason for subtropical deserts is uneven heating of Earth. So the Earth is not heated. The Earth does not receive the same amount of heat all over its surface from the sun. The tropical equator gets the most direct sunlight, so the equator is warmer, for example, than the poles. Air actually will rise there at the equator. It will rise, it will lose all of its moisture, and then around 30 degrees we have descending air, so air actually moves down vertically, and it is very, very, very dry. So this creates subtropical bands of deserts around 30 degrees north and south, because the air is very, very, very dry. So there is no water in the air around that area. So these create bands. We call them bands of deserts because it's generally all around the world on this 30-degree north line and all around on the 30-degree south line. We have these subtropical deserts. A rain shadow desert, it's a little different. So these are actually caused by the surface topography. So as warm air is forced over a mountain, so here we have our mountain, it is next to our ocean, warm and moist because it's over the water, so there's going to be a lot of moisture in the air. As it is forced up over the mountain, because the air can't move through the mountain, it has to move up, it'll just go up and over. As it moves up the mountain, the air is forced upward vertically. It's going to actually cool down and it will condense and start to rain. So on one side of this mountain, it's going to be there's going to be a lot of rain, there's going to be a lot of moisture, because as that air rises up, it's going to condense and all of the water will fall out. All of the water will rain out. So by the time the air gets to the top of the mountain, it's completely dry. There is no water left as the air moves down over the other side of the mountain. So this vertical motion of the air being forced up the side of the mountain causes all of the rain to fall out on the ocean side of the mountain, the windward side of the mountain. So when the air flows down the other side, it's completely dry. So we call this rain shadow because it's sort of in the shadow of all of the rain on the other side of the mountain. So one side of the mountain will be very lush and green, the other side will be completely desert. Our coastal deserts are also common. So what usually happens is that we have colder air masses following colder ocean water, and colder air can't hold as much water vapor in it. So cooler air cannot hold as much water, can't have as much water vapor to form clouds, to form rain. So when we have cold water moving, in this case, this is the southern hemisphere, so the water is moving north up against this continent. The ocean water is cool. It's going to keep the air above it cool, which means that air will not be able to hold much water vapor. So when this very dry air moves over our over the landmass, there's not going to be much air there's not going to be much water in the air to begin with. So there will be very cool air close to the ocean surface, just like here we have cold ocean, so the air right above the ocean is going to be very cool. It's not going to hold a lot of water, which means that the beach area near this cold ocean, so the shallower area near this cold ocean, is going to be desert. So the example here is the Atacama Desert, which is actually the driest place on Earth. It does not receive any rainfall at all throughout the year. The only water that it gets is occasional mist that comes up over the ocean. So when the ocean warms just slightly, they a few times a year get a little bit of mist to support the plants. Very few plants and animals that actually live in this Atacama Desert, the driest place on Earth. The last type of desert is actually the polar desert. So we have two polar deserts on both of our poles. So the North Pole and the South Pole are technically deserts because, as I said, cooler air cannot hold as much water vapor. So if you can imagine, the coldest air on Earth is at the poles. This cannot hold any moisture. Very little water in air that is so cold, meaning there's not going to be very much precipitation in an area that is this cold. So the North Pole and the continent of Greenland, as well as the South Pole, this continent of Antarctica, are actually deserts because they receive very little precipitation because the air there is so cold that it actually can't hold any water vapor at all. So now we know our types of deserts. Let's think about desert erosion and weathering. So what do our desert landscapes actually look like? So erosion is generally, as we know, by water and by wind. We're going to go through how that affects deserts, weathering, formation of soil, and also deposition. So physical weathering is dominant in desert regions. So most of the weathering that occurs in desert regions is physical weathering. Why maybe would we not expect chemical weathering in deserts? We have a lot of physical weathering, but there's no chemical weathering. Why is that? It's because chemical weathering relies on water. So physical weathering is dominant, generally gravity and wind, not water, wind will be the dominant causes of weathering. Chemical weathering requires water. So all of our chemical weathering requires some sort of water to break down the rock and the sediments there. So because there's no water flowing, there's very, very little chemical weathering occurring in desert areas. One thing that does occur rather often is called desert varnish. So desert varnish creates these very dark surfaces along exposed rock. So desert varnish occurs very, very slowly. And the thickness and also the darkness, how dark is the varnish, actually shows us how long that rock has been exposed at the surface. So this is really the only chemical sort of reaction that happens. It's being oxidized. So for example, you could guess that this area of rock that is covered in this desert varnish has been exposed to the elements much longer than this part of rock right here, closer in the image, which has no desert varnish. So if you're in the desert and you see these dark spots, it's not always in lines like this. It can often be more clumpy. See this really dark, it looks dirty. Like it really looks like the rock needs to be cleaned. You know that that rock has been exposed to the elements for a very, very, very long time, especially compared to rock nearby that doesn't have that visible desert varnish. So erosion by water in deserts is very rare. It does not normally happen. It generally only occurs during a flash flood. So we learned about flooding, of course. Desert areas, the soil is not able to absorb water because it's very compacted. It doesn't normally see water, so there isn't a clear way for water to flow through the soil or the sand. Flash floods can erode sand very quickly. So because many deserts have loosely, not loosely compacted, it's very compacted sand, but it's not cemented together. That's the word I was looking for. The flash floods can actually erode quite a bit very, very quickly because the sediment is not cemented together. It's just loose sediment. And what this can do is leave behind drainage areas. So for example, if this flash flood moves through this area, as you see from the figure, this region is going to be eroded significantly. There's going to be a lot of sediment carried out by that flash flood. When that water moves through, it's going to be left with this drainage basin, this very eroded area here where all the water flowed, compared to other areas that were not experiencing any erosion. So because there is not water erosion regularly, when there is water erosion from a flash flood, it can be very extreme, and it's usually just concentrated to where the water flows. So wind is the normal eroding factor for deserts. So we do not see a lot of rain. So wind is really the serious erosion factor. So high winds, strong winds can create wind storms. So as I said, there's no cement really holding the grains together. So it's similar to when a river flows and we have the suspended load and the bed load, it's really similar the way that wind causes loose grains to be transported. So depending on the size of the grain and the strength of the wind, it's going to depend on which size grains are lifted and moved and how far. So very, very small grains might be lifted quite a bit. Bigger grains maybe will just roll along. The biggest grains maybe won't move at all. This guy maybe will just turn over, whereas these are actually being lifted up and moved. So it depends on the size of the grains and also the strength of the wind. So the higher the wind, the more that sand and dust is going to be moved. So for example, he's covering his face. There's some strong wind because all of this gray, brownish in the background is supposed to show very, very, very tiny pieces of dust that are actually suspended in the air. The wind is moving so quickly that there is dust and sand suspended in the air, the same way that we would expect in a flowing river. So here is a picture of a dust storm from Phoenix, Arizona. I actually have a video of it that I want to show you. Where is it? Here we go. So it's a news report. I want to show the video of the dust storm actually moving.
Wow, look at this. What else can you say about a wall of dust that's about a mile high and maybe 50 miles wide that descended on downtown Phoenix and swept across the valley east to west? Skyfox capturing this massive dust cloud rolling through downtown Phoenix. Buildings disappearing. The tallest building downtown dwarfed by a mile-high wall of dust. All of downtown blanketed in a matter of minutes. Yeah, in a word, it's wicked. Look at Chase Field being swallowed up tonight. And right across the street, U.S. Airways. It's eerie, has it?
So this is not sped up. So this video is actually in real time. That is how fast the wall of dust is moving. That is how quickly that dust storm really is moving. So these can be pretty dangerous. If I can zoom forwards, here's a plane that makes it out just in time. I would not be thrilled to be on that plane, but you can actually see how huge this dust storm is. So there's a large amount of high energy wind blowing through this region, and it picks up a huge amount of dust on its way. Okay. So dust storms, they can be very, very dangerous. Another thing that happens is what we call deflation. So deflation is that the surface of the desert can actually lower. So due to wind erosion, the level of the surface actually lowers. Because over time, we have what we call blowouts. So this means that over time, these strong winds and these dust storms are going to come in and actually remove all of the small grains of dust. So all the small grains are going to be removed, leaving behind the heavier grains. The heavier grains will eventually create a layer, which we call lag deposits, because it's what's left behind. So when there's a really large layer of larger grains on the surface, we know that it's because this area has experienced a lot of wind that has removed all of the smaller layers of dust. So because we're removing so much material, the surface is actually deflated. It actually moves downwards, and all that's left on the surface are the larger grains, the larger clasts that can't be removed by the wind. So some desert landscapes here, you don't need to know all of them. I'm going to go through just a few of them. We have alluvial fan, which you already know about. We're going to talk about just a few of them in examples in the rest of this slide, the rest of this PowerPoint. Hopefully my computer doesn't die. It might. We'll see what happens. So the evolution of different landscapes really is just due to what is the landscape made of and how strong is the erosion. So for example, an area that already is jointed, so there's all these parallel joints, As erosion continues, those joints are going to be eroded and eroded and eroded away until we get something that looks more like this, until all of that rock is actually eroded away. Something that isn't jointed, so it doesn't already have these cracks, is going to erode just around the outer surfaces. So these areas, these mesas, these taller areas are just going to get smaller and smaller from all sides. If there's joints already involved, that is going to that's going to control where the maximum erosion occurs. So hoodoos, it's one of the things listed a couple slides back. One of my favorites, they're very, very cool. This is Bryce Canyon here. They're like chimneys of columns of rock. And it's something like this. So some chimney that is what's left over. It might be, one of these could be a chimney as well. Left over after erosion. When it's just a singular left alone column, we call them a hoodoo. So there has been quite a bit of erosion here, causing all of these individual hoodoos here. Playas. Playas are very cool. They are actually desert lakes that have no outlet. So it's a lake that fills during a flooding event, but there's nowhere for the water then to go. So it accumulates there and then over time evaporates. So it's so hot, the water stops flowing in, so the whole lake is going to evaporate, which means all of the solid minerals that were in the water are going to crystallize out of the water there. So you end up with a lot of minerals, a lot of salt generally in these playas, because for most of the year they're actually dried up. So you'll have sort of a salt bed in the middle of your desert. That means that is a playa. That is the area that fills with water and then evaporates once the flood is over. So here's an example. It's white because it's showing you the salt bed left over there. So desert pavement is something very cool. It's a type of rock layer that only really forms in the desert. So it's an incredibly tightly packed sort of mosaic of grains. So they form because there is no water. So over time it is just packed and packed and packed and packed and packed. And all of the smaller grains might be removed, again, from high winds, from storms. So what happens over many, many, many years is all of this is actually a layer of rock now. So it has become all one layer of rock. You wouldn't be able to just pick up these small pieces because they fit so perfectly well together. It's going to form a very smooth surface. So from the wind blowing over the surface and from the time where it has not been displaced by water, nothing has caused this to move. Desert pavement actually forms on the surface of some deserts where the rocks end up fitting together so perfectly that it becomes one thick layer of desert pavement. We call it pavement because it's sort of made up of all different types of rock. So it can be very, very cool. Very thick and very sturdy as well. So here we go. We have, it's sort of, they call it a mosaic of tiles, but it's not tiles, it's rocks. So large pebbles that end up accumulating because all of the dust is removed. So the dust will be removed, most of the dust will be removed. Anything left is going to just settle like perfectly in between the pebbles. So it's going to fill in the cracks in between the rocks very, very perfectly to the point where there's no space left. There's never any water to remove those grains, so the dust can settle very perfectly and fill in to create a full layer of rock. It's very, very cool to see. The next feature are sand dunes. So we talked about these a little bit when we talked about sedimentary rock, because sedimentary rock can actually form because of sand dunes. So we know a little bit about how sand dunes grow, how sand dunes move. The wind actually blows our sand particles, so it's going to move up and up and up till the point where it is too steep and we find the slip face. So the wind is blowing in this direction, causing our sand to accumulate to the point where it's too steep and it starts to slip. So sand dunes actually grow and they move over time, so they don't stay in the same place. This sand dune is actually going to shift as the wind moves it. So there's different types of sand dunes. You do not need to know the different types, but I did want to show you because you might see varying patterns. So different patterns of sand dunes. This is sort of the more typical, just striped sand dunes, but just depending on the way that the wind is blowing is going to change how your sand dunes look. So don't worry about the different types and the names, but I did want to show you that sand dunes can take different shapes depending on how the wind is moving, both the speed and the direction of the wind. So those are just the landscapes that we're going to focus on. If you want to learn more, there's more in the textbook. A lot of it is things that we have talked about just a little before or in different sections. Our alluvial fans, we have our arches, here's the desert pavement, our playa lake, all sorts of different sand dunes. This is the chimney or the hoodoo. So if you want to learn more about desert landscapes, you can look at all of these, but those are just the ones we're going to go through. You'll have to look at a few in your lab today, and the lab will also use some Google Earth. So for the last section of the lecture, I just want to go over desertification. So this is where human activities are actually causing an expansion of desert areas. So we are actually expanding our desert into areas that should not naturally be desert. We're actually seeing an expansion of desert area. So this is mostly due to overpopulation, overgrazing by the animals that we are farming, agriculture, if not using good practices, and groundwater use and surface water use. So using too much water, taking too much water means there's not enough water to sustain other areas, so we're causing deserts to actually grow. So this is not great because we're ruining the ecosystem that is there, turning it into desert, and also we're increasing the availability of dust. So now if we're growing the area of desert, we're growing the area of dry dust, ready to be moved by wind, ready to be moved by windstorms. So this can be really dangerous for us because it can carry really dangerous chemicals and disease. Windstorms can be very dangerous, especially if it is new dust, so we're not exactly ready or we are not accustomed to having dust storms in these areas. If now we have more availability of dust in terms of area, we can see more frequent, more severe, and more widespread dust storms in the future.